Dear students, welcome back to a new mathematics session. In today's session, we shall discuss a new chapter, that is chapter number 3, Matrices. Let's move on to the topic. Consider 4 numbers, that is 1, 3, 5 and minus 7. So these 4 numbers we can arrange it in different ways. The first way of arrangement is 1, 3, 5, minus 7 in square bracket, and this arrangement is having one row. This is the row and it is having only one row and 4 columns. This is the first column, second column, third column and fourth column. This is one way of arrangement. And another way is this way, that is it is having 4 rows, first row, second row, third row, fourth row and only one column. This arrangement is having one row and 4 columns, and this arrangement is having 4 rows and only one column. And another way also we can arrange, like first 2 numbers in the first row and the second 2 numbers in the second row. This is also another way of arrangement, and here it is having 2 rows, first row, second row and 2 columns. This is first column and this is second column. And this way of arranging numbers or elements or anything is called matrix. Means a matrix is a rectangular array of numbers or functions. So an arrangement, an ordered arrangement which is in a rectangular format. So you can see here this is 1 row and 4 columns, and this is 4 row and 1 column, and this is 2 rows and 2 columns. Consider another situation. Suppose Radha has 15 notebooks and 6 pens. Fauzia has 10 notebooks and 2 pens. Simran has 13 notebooks and 5 pens. This is a situation or scenario is given to us. How we will be arranging this situation? That is, when we arrange it, there are 3 persons. One is Radha, Fauzia and Simran, and they are talking about their number of notebooks and pens in which they are having. And Radha is having 15 notebooks and 6 pens, and Fauzia is having 10 notebooks and 2 pens, and Simran is having 13 notebooks and 5 pens. When we rearrange it, this one again, this can be arranged in this way. That is 15, 10, 13 and 6, 2 and 5. This 15, 10 and 13 represents the notebooks, and 6, 2 and 5, this represents the number of pens. So the first column belongs to Radha. So Radha is having 15 notebooks and 6 pens. So here 15 notebooks and 6 pens. So this column belongs to Radha, and this column belongs to Fauzia, and this column belongs to Simran. So this is a way of representing a particular situation in a matrix format. So in this matrix we are having 2 rows. This is the first row and this is the second row, and there are 3 columns. First column is this one, second column is this one, and third column is this one. So now we have learned that matrix means it is a rectangular arrangement of numbers or functions or anything. So any arrangement or display of this kind, this particular kind, means a rectangular arrangement, is called the matrix. Next, let's discuss the definition of matrix. A matrix is an ordered rectangular array of numbers or functions. It is a rectangular arrangement of numbers or functions. The numbers or functions are called the elements or the entries of the matrix. Whatever be the numbers we write inside the matrix, they are called the elements or the entries of the matrix. And we denote matrix by capital letters. English alphabet capital letters we will use to represent a matrix. So let's go with some examples. Here A is equal to, this is the capital letter we use for representing the matrix. A is equal to matrix -2, 5, 0, root 5, 3, 6. And here it is having 3 rows. This is the first row, second row, third row. 3 rows and 2 columns. This is the first column and this is the second column. Another example, if you take B is equal to matrix 2 plus I, 3, -1 by 2, 3.5, -1, 2, root 3, 5, 5 by 7. So there are 3 into 3, 9 elements are there, and each one is called the elements. 2 plus I is an element, 3 is an element, -1 by 2 is an element of this matrix B. and here it is having 3 rows and 3 columns. When you check, this is the row, first row, second row, third row, first column, second column, third column. So total 3 rows and 3 columns. Another example, if you take C is equal to matrix 1 plus x cube, 3, cos x, sin x plus 2, tan x. And this is having 2 rows, first row, second row, and 3 columns, first column, second column, and third column. And each one is called its element of the matrix C. 1 plus x is an element, sin x plus 2 is an element, tan x is an element, etc. So this is the definition and examples of matrices. Next, we shall discuss about the order of a matrix. Let's consider a matrix A is equal to matrix 3, 2, 1, 4. Here it has 2 rows and 2 columns. 2 rows and 2 columns. This is the first row, this is the second row, first column, second column. We write the order as 2 by 2. We write it as 2 into 2 and we read as 2 by 2. And first one represents the number of rows and second one represents the number of columns. So the order of the matrix, if you want to write, we just count the number of rows first. There are 2 rows, so we write 2. Then we put a multiplication symbol, that is into. Then number of columns. This is first column, second column, so 2 columns. And we read as 2 by 2. Remember, we have to read this one as 2 by 2, order of the given matrix A. So 3, 2, 1 and 4. 3, 2, 1 and 4 are called the elements of the matrix. We write the matrix A as, this is the general form. There are 4 elements are there and this is the first element. We represent it as A11. Small letter A, 1, 1 means first row, first element. Then first row, second element. Here second row, first element. Second row, second element. Once again, A11, A12, A21, A22. All representing by using small letter A. So A11, suffix 11 means first row, first element, first row, second element, second row, first element, second row, second element. This is the general representation of a 2 by 2 matrix. 2 by 2 matrix. 2 rows and 2 columns. So A11, element in first row, first column. A12, element in the first row, second column. A21, element in second row, first column. A22, element in the second row, second column. Then A11 is equal to 3. A11, if you are asked, if you have given a matrix like this and if you are asked to write A11 means first row, first column, first row, first element, you have to write first row, first element is 3. A12 means first row, second element, first row, second element is 2. Next A21, second row, first element, second row, first element is 1. A22, that is second row, second element, second row, second element is 4. So this is the way we have to identify the elements of a matrix. Then for matrix B is equal to 3, 2, 1, 4, 5, 3. It has 3 rows and 2 columns. First row, second row, third row, 3 rows and 2 columns. So the order is 3 by 2. Remember, 3 by 2. 3 rows and 2 columns. We write matrix B as B is equal to matrix 3, 2, 1, 4, 5, 3. The same matrix we will write and in the suffix we will write its order, that is 3 by 2. Just on the right bottom, 3 by 2 we write, and this way is the representation of order of a matrix. Just on the right bottom we write the order, that is 3 by 2. Next we shall discuss matrices of different order. How we will be identify the order of a matrix. First of all, we will write some matrices and we will be writing their order. So first matrix is 9, 5, 2, 1, 8, 5, 3, 1, 6. So for finding out the order, first we have to count the number of rows and next we have to count the number of columns. So it is having 3 rows. First row, second row, third row. 3 rows and 3 columns. So order is 3 by 3. Next matrix, if you consider matrix 1, 2, 5, 8, x, z. First we have to count the number of rows. It is having only 1 row. And 1, 2, 3, 4, 5, 6 columns. 1 row, 6 columns. So the order is 1 by 6. Next matrix 5, 9, 3, y tan inverse x. First we have to count the number of rows. 1, 2, 3, 4, 5. 5 rows and only 1 column. So the order of the matrix is 5 by 1. Next is sin x, cos x, tan x, cot x. Sin y, cos y, tan y, cot y. Sin z, cos z, tan z, cot z. It is having 1, 2, 3. 3 rows and 1, 2, 3, 4. So 4 columns. So 3 by 4 is the order. Next, the general form we will discuss. In general, M by N matrix has the following rectangular array. M by N, first represent the number of rows, second one represent the number of columns. M number of rows and N number of columns. A general way of representing this matrix means which is having an order M by N is A11, A12, A13, etc. A1N. A21, A22, A23, etc. up to A2N. Likewise, AM1, AM2, AM3, etc. up to AMN. So, M rows and N columns. So, this is the general representation of a matrix. Shorter than this, we can make this matrix also again shorter. That is, A is equal to square bracket we have to put and small letter Aij. Small letter A represent each element of the matrix, individual element. I means the number of row and in which column it belongs. So Aij are on the suffix, on the means on the right bottom. So Aij, and on the outside of the bracket we have to write M by N, outside right bottom. That means on the suffix you have to write M by N. So the general form, in short, we can write the matrix as A is equal to square bracket Aij of order M by N. So Aij is an element lying in the ith row and jth column. So if I1, 2 means it is a first row, second element. So that is the way we have to identify the element. Next, we shall discuss how to find out the number of elements in a matrix. For matrix A is equal to 3, 2, 1, 4 of order 2 by 2, means 2 rows and 2 columns. The number of elements can be calculated by 2 into 2, means number of rows into number of columns. Number of rows means 2 rows here and 2 columns. So 2 into 2, that is equal to 4. Then for another matrix, matrix 5, 9, 3, y tan inverse x. For writing the number of elements, what we have to do is first we have to write the order. Order is there are 1, 2, 3, 4, 5. 5 rows and 1 column. That means 5 into 1 equal to 5. Next, another matrix B is equal to matrix 3, 2, 1, 4, 5, 3. So it is having 3 by 2 order, 3 rows, 1, 2, 3, 3 rows and 2 columns. 3 rows and 2 columns, when we consider the number of elements is 3 into 2, that is equal to 6. Next, for another matrix 1, 2, 5, 8, x, z. It is having only 1 row but 1, 2, 3, 4, 5, 6 columns. That is, number of elements is 1 into 6, that is equal to 6. So, in general, number of elements can be calculated by multiplying number of rows and number of columns. That means number of elements is equal to number of rows into number of columns. Next, we shall discuss the types of matrices. First one, column matrix. A matrix is said to be a column matrix if it has only one column. If a matrix is having only one column, then we can say that it is a column matrix. Let's consider an example. A is equal to matrix 0, root 3, minus 1, 1 by 2. And it is having only one column and 1, 2, 3, 4 rows. So the order is 4 by 1. Number of rows and number of columns. 4 by 1. It is having only one column. So it is an example of a column matrix. In general, A is equal to matrix Aij of order M by N. First one stands for the number of rows. Second one stands for number of columns. Here the number of column is 1. Is a column matrix of order M by N. Next is a row matrix. Row matrix. In column matrix, we have discussed that a matrix is said to be column matrix. It has only one column. Similarly, in row matrix, a matrix is said to be a row matrix. It has only one row. So, example, if you take B is equal to matrix minus 1 by 2, root 5, 2, 3. and it is having only one row. Clearly it is visible here, only one row and 1, 2, 3, 4 columns. So 1 by 4 means number of rows and number of columns. Order is 1 by 4 is a row matrix. It is a row matrix because it is having only one row. This is a column matrix because it is having only one column. So in general, B is equal to matrix Bij of order 1 by n. Here number of rows is 1, number of columns n. So 1 by n is a row matrix of order 1 by n. So in general, this is the general form of a row matrix, that is Bij of order 1 by n. General form of a column matrix is Aij of order m by 1. Third one, it is a square matrix. A matrix in which the number of rows are equal to the number of columns is said to be a square matrix. In a matrix, if the number of rows and number of columns are equal, then we can say that it is a square matrix. So, example, A is equal to 3 minus 1 0, 3 by 2, 3 root 2 1, 4 3 minus 1. Clearly, it is having 3 rows, 1, 2, 3 and 3 columns, 1, 2, 3. So number of rows and columns are equal, 3 by 3 means it is a square matrix of order 3. Here in this case you might have noticed order is writing by using only one value. Means for a square matrix, since the number of rows and columns are equal, it is enough to write only one value. That means number of rows. Surely it will be equal to number of columns. So it is a 3 by 3 matrix. So we write it as a square matrix of order 3. In general, A is equal to matrix Aij of m by m. Here both letters are same, means number of rows and number of columns are equal, is a square matrix of order m. Only one value is enough to represent the order of a square matrix. Next is a diagonal matrix. A square matrix B is equal to Bij of order m by m is said to be a diagonal matrix if all its non-diagonal elements are 0. So diagonal matrix definition is applicable only in square matrices. Means a square matrix is a general form Bij of order m by m is said to be a diagonal matrix if all its non-diagonal elements are 0. Means if you take a matrix A is equal to matrix 4, it is having only one element, so this is a diagonal matrix. And when you consider B, this is a little bit easy to understand rather than just comparing with this one. So B is equal to minus 1 0 0 2. This is a square matrix of order 2 by 2. 2 rows and 2 columns. And a diagonal, as you know, diagonal means this is the diagonal. So this elements, when we consider, it is minus 1 and 2. Only this diagonal is having elements and all other non-diagonal, means this is a non-diagonal element. People may think that this also a diagonal, but we consider only this one as a diagonal and the other elements are non-diagonal elements. So other elements are 0. So this is an example of a diagonal matrix. Next, 3 by 3 matrix, if you take, it will be little more clear. That means diagonal elements mean these are the diagonal elements, that is minus 1.1, 2 and 3. Other than these elements in this matrix, all other elements are 0. So this is an example of diagonal matrix. Next is a scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. So a scalar matrix means, scalar matrix definition is applicable only with the diagonal matrix. Diagonal matrix, you know that all other non-diagonal elements are 0. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Diagonal elements, you know that this is the diagonal element. So example, if you consider, this is matrix 3. So it is having only one element. So just to keep it as an example, but it is difficult to understand. So we will go with another example, that is 2 by 2 square matrix. That is here minus 1 0 0 minus 1. Diagonal elements means this is the only one diagonal, that is minus 1 and minus 1, they are equal. So it is a scalar matrix. And 3 by 3 matrix, if you take, that will be little more easier for you to understand. So 3 by 3 matrix, first of all it is a square matrix, and the second it is a diagonal matrix because all the other non-diagonal elements are 0, and it is a scalar matrix because diagonal elements are equal. Once again I tell you with this example, this is first of all a square matrix because number of rows and number of columns are equal. And next, this is a diagonal matrix because all non-diagonal elements are 0. Other than these diagonal elements, all the other elements are 0. And this is a scalar matrix because all these elements are equal. That's why it is scalar matrix. Next, we shall discuss about the identity matrix. A square matrix in which elements in the diagonal are all 1 and the rest are all 0 is called an identity matrix. So by the definition itself it is quite clear. A square matrix, it is a square matrix means number of rows and number of columns are equal, in which elements in the diagonal are 1 and rest all are 0. So it is quite simple to write. This is just like before, we write only 1, and here 2 by 2 square matrix and the diagonal elements are 1, and it is a 3 by 3 matrix, diagonal elements are 1. So these are the examples of identity matrices of order 1. This is order 1, this is order 2, this is order 3. Means this is only 1 row 1 column, and this is 2 row 2 column, and this is 3 row 3 column. That's why we tell that matrices of order 1, 2 and 3. Next one is a zero matrix. A matrix is said to be zero matrix or null matrix if all its elements are 0. So zero matrix or null matrix means all the elements in that particular matrix will be 0. Examples: matrix 0, 0, 0, 0, 0. Next is 0, 0, 0, 0, 0, 0. Means this is not a square matrix, means it is having only 2 rows and 3 columns. And here it is having only 1 row and 2 columns. Zero matrix means these are the examples, means all the elements must be 0. Next is equality of matrices. How we will be considering that two matrices are equal. Two matrices A is equal to matrix Aij and B is equal to matrix Bij are said to be equal if they are of the same order. First of all, they should be of the same order. Order means number of rows and number of columns should be equal in both the matrices. Next one, each element of A is equal to corresponding element of B, means their corresponding elements must be equal. First of all, it should have the same order. Both matrices should have the same order. Then each corresponding element also should be equal. For example, matrix 2, 3, 0, 1 and matrix 2, 3, 0, 1 are equal matrices. First we will check the first condition. It is of the same order. This is 2 by 2, 2 rows, 2 columns. This also 2 rows, 2 columns. So they are equal. Means they are of the same order. Next, each element of A is equal to corresponding element of B. This is first row, first element is 2. Here also first row, first element is 2. Second row, second element, first row, second element is 3. First row, second element is 3 here. Then second row, first element is 0. Here also second row, first element is 0. Second row, second element is 1. Second row, second element is 1 here also. So these two matrices are equal. Next, matrix 3, 2, 0, 1 and 2, 3, 0, 1 are not equal matrices. It is quite clear because first element, if you check, this is 3, this is 2. Corresponding elements are not equal. But they are of the same order, but corresponding elements are not equal. Two conditions must satisfy. Since their corresponding elements are not equal, they are not equal matrices. Dear students, today we have started a new chapter, that is matrices, and we have discussed the basic concepts of matrix. I request all the students to go through the definitions and memorize it properly. And while practicing, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.